Engineer open house. Give me a sec. We are recording this presentation until the Q&A session. Please keep your cameras off and please mute yourself. Okay, next slide. So for the agenda, we have the EBMUD overview, the EBMUD organization. We'll talk about our open positions, the career ladder, the rotation program, salary and benefits, how to apply, and we'll end with question and answers and our closing remarks. So we have a couple of speakers today. I'm Winnie Jang. I'm an assistant engineer in the water distribution planning division. We also have Max Pfeffer, who's an associate civil engineer with water supply improvements, Bill Majori, who's a senior civil engineer of water distribution planning, Lori Work, who's a senior civil engineer for operations and maintenance process engineering, John Kaiser, who's a plant maintenance supervisor of the wastewater treatment, Brad Ledespa, who's a senior civil engineer for water supply improvements, and lastly, we have Tim McGowan, who's a senior civil engineer for water distribution planning. So passing it off to Max Pfeffer.
All right, thanks, Winnie. Hey, everyone. My name is Max Pfeffer, Associate Civil Engineer in Water Supply Improvements. I'll be taking it over from Winnie and giving you an overview of who EBMUD is and what our organizational structure is like. So as you can see on the slide, we are EBMUD. We're known by several different names. Our full title is the East Bay Municipal Utility District. In quotations on the slide, we have a couple nicknames. Internally, we refer to ourselves as the district. Some people call us EBMUD, or some also call us EBMUD. So we are a publicly owned utility serving Alameda and Contra Costa counties. And for those that aren't in the area, it's the East Bay of the San Francisco Bay Area. And since we are publicly owned, that means we are a not-for-profit organization. We are actually our own government. So we are unlike PG&E and other private utilities where they can technically profit. We are a not-for-profit utility. And our main goal is to supply high-quality drinking water to 1.4 million customers. And also we provide wastewater treatment to about 685,000 customers. So our two main tenants of EBMUD are providing drinking water and providing wastewater services as well. In our organization, we have about 1,950 full-time employees. All right. And I'll just describe the pictures below a little bit. On the left is a photo of the Pardee Dam and Pardee Reservoir, which I'll talk about a little later. Center photo is from our administration building located in downtown Oakland. And the right side is a photo of the main wastewater treatment plant, which is located in Oakland, right along the San Francisco Bay. All right, so this is a picture of our service area. So this is where all of EBMUD's customers are. So the large outline you see in the darker green, that is our water service area. So that is where 1.4 million customers receive drinking water from us. So we are located in downtown Oakland, which I'll highlight right here. Our headquarters is there. We serve water all the way up through the Hercules, Rodeo, Crockett area, all the way up to the Richmond Bridge, and all the way down to the Hayward area. So a big portion of the inner East Bay we serve water to. We also extend past the East Bay Hills into the Lafayette, Moraga, Orinda area, also into Walnut Creek and down into San Ramon as well. In the light, in kind of the hatched pattern you see, the smaller area within the green area, that's where we provide wastewater services to. So we collect wastewater from the local sewers from the cities, and we treat them at various facilities along the East Bay, primarily the main wastewater treatment plant, which is located roughly about here. So EBMUD has a fairly large service area. We serve a very large and diverse customer base. So I think that's part of what makes us an interesting agency is we have a lot of different stakeholders that we serve as a public agency. So yeah, that's our service area. There's our headquarters approximately. All right, so EBMUD has three main parts to our mission statement. And the first one is to manage the natural resources with which the district is entrusted. So East Bay Mud is unique in that we have our own water rights that we own attached with the Pardee Dam and the Comanche Dam up on the Mokelumne River. And I'll have a picture of the Mokelumne River on the next slide. So East Bay Mud owns its own water rights, and we also pay for our own fishery service that we have a salmon hatchery on the Mokelumne River, which is there to help protect the fishery on the Mokelumne River. So managing natural resources is a big part of what we do at East Bay Mud. The second is to provide reliable, high quality water and wastewater services at fair and reasonable rates for the people of the East Bay. So like I mentioned at the beginning, we are a not-for-profit agency. Everything our customers pay for, every dollar goes back into serving their water and wastewater services in one way or another. And our budgeting and finance teams have actually won national awards for how clear our budgets are and how we set our rates. So we definitely take this to heart that every dollar that's coming in from our customers is going back into providing that reliable, high quality water and wastewater services. And third is to preserve and protect the environment for future generations. So again, this is kind of a unique mission for a water agency that you see two of our mission statements are related to environmental areas. The first two, natural resources, the second one more generally about the environment. So our wastewater services, we put our effluent from the wastewater treatment plant directly into the San Francisco Bay, and we take that very seriously on what is the quality of water going into the San Francisco Bay, and how can East Bay Mud be a good steward for the environment. So actually just coming up in a couple weeks, East Bay Mud is hosting a San Francisco Bay cleanup day. So on Saturdays, I think it's one Saturday in September, employees will be coming out and cleaning up the shoreline of San Francisco Bay to help further that mission of preserving and protecting the environment for future generations. All right, so here's that slide I mentioned about talking about our infrastructure. So starting at the headwaters of our water supply is the Mokelumne River watershed. The Mokelumne River is located just adjacent to Yosemite National Park in the Tuolumne River watershed. So it's located in the Sierra Nevada foothills. So it's, as you can see on the map, we're south of Lake Tahoe, and we're also north of Yosemite National Park. So we're located about 2 hours east of the East Bay. And I'm currently in Oakland, so it's about 2 hours from here. We collect water from the Mokelumne Rivershed, and we store that in two large reservoirs, which are essentially lakes. We have Pardee Reservoir, which is our main supply for our municipal water supply. So the drinking water that gets delivered to the Oakland area and our service area generally comes from Pardee Reservoir. And downstream of Pardee Reservoir, we also have Comanche Reservoir, which serves as flood control for the Central Valley, and particularly for the Lodi and Stockton areas. So although Pardee is mainly used just for drinking water, Comanche also serves a very important purpose for flood control and also managing downstream water user rights. Since we are not the only users of water in the Mokelumne River, that Comanche also serves an important purpose there. From Pardee Reservoir, the water that serves the East Bay enters the East Bay Mud Mokelumne aqueducts, which are 3 85-mile long water supply pipelines that travel from Pardee Reservoir in the foothills down through the Sacramento San Joaquin Delta, here into the East Bay and into our service area. And later on, you might hear a little bit about this, but the resilience is also something we are working on, and the Mokelumne aqueducts are running through the Delta. One project we're looking at is replacing those aqueducts for something that is more resilient in the future. So it's very, from my perspective as kind of a young engineer coming to East Bay Mud, it's really cool that we own all this infrastructure and East Bay Mud manages it, which makes it very interesting for us as engineers. That we get to plan these facilities, we get to figure out how to maintain them, how do we do all those sorts of things. So that is our main everyday sort of infrastructure. The second thing you'll notice on here is the Freeport Regional Water Facility, which is a core part of our dry water management plan. So the Freeport Regional Water Facility brings in supplemental supplies during drought periods. So East Bay Mud is currently experiencing a stage 1 drought, which the board of East Bay Mud's board authorized us to bring in supplemental water supply into our service area. So actually later this year in October, we'll be turning on the Freeport facility, and we'll be bringing in Sacramento River water in through the Freeport Regional Water Project, bring it in through these dark blue pipelines you see here into the McColmy aqueducts. So this Freeport facility is our hedge against drought in order to mitigate any sort of supply loss in the McColmy River. So that's another interesting aspect of East Bay Mud is we not only own our own infrastructure every day, but we actually own infrastructure for drought years as well. And you won't see that at many other agencies. So it's pretty neat part of our water supply picture. And I will mention if anyone has questions, feel free to type them in the chat. If you want to ask a question verbally, like turn on your camera, unmute yourself, we'll be doing Q&A at the end. So there's two options if you have questions on anything we're talking about in this presentation. Okay. So moving on to the East Bay Mud departments, where do we actually have engineers that work within our department? I'll give you a lay of the land of where engineers work across East Bay Mud. So just starting at the very top of our organization, the decision makers at our agency are a publicly elected board of directors. I believe we have 7 directors. Someone can correct me if I'm wrong. It might be 6. They are publicly elected, and they're essentially like representatives you would elect for any other government agent or government body. So these directors are elected by the public, and they're charged with running East Bay Mud from a policy level. They choose the general manager, which is currently Clifford Chan. Clifford is born and raised East Bay Mud, been here a very long time, and admired by a lot of people. So Clifford Chan is kind of running our organization as the general manager. And all these different departments listed here report to the board of directors and general manager. So the first is the department I work in, which is the Water and Natural Resources Department. This department is charged with protecting our watersheds and our water rights. So in this department, we have our fish biologists, we have our water supply engineers, we have the engineers working on drought supplies, and we also have our engineers who are working on just our everyday water rights to make sure we are staying in compliance with state law and defending our water rights going into the future. The second department we'll mention is the Operations and Maintenance Department. As the name suggests, they are charged with maintaining our water system facilities and pipelines. So like I outlined on the previous slides, East Bay Mud owns and operates a lot of infrastructure. So the Operation Maintenance Department is one of our largest departments at East Bay Mud. Our third department is the bread and butter for engineering, our Engineering and Construction Department. So the Engineering and Construction Department both plans, designs, and constructs many of our system facilities and pipelines. So as you can imagine, most of our engineers are located in this department. But I'll show you in a little bit, we actually have engineers in all 5 of these departments shown. The fourth we have is wastewater. Wastewater is charged with cleaning the wastewater generated within the East Bay and protecting the San Francisco Bay from harmful pollutants that had come from the wastewater treatment plant process. And our last division we'll mention is the Water Conservation Division. As we're entering drought, water conservation is a very important part of how we protect against droughts and make sure our customers understand what we need our customers to do during periods of drought, whether that be replacing their lawns with something that's more efficient, reducing water use, all that. So they are charged with implementing the district's water efficiency goals. So here's some statistics on the number of civil engineers that are within our organization. So starting at the total, we have about 200 civil engineers across East Bay Mud, 52 of which are entry level. So that's our junior engineer position, which we're here talking about tonight. The Water and Natural Resources Department has 24 engineers, 2 of which are entry level. Operation Maintenance, 21, 9 of which are entry level. And like I mentioned, engineering construction has about half, 105 civil engineers, 29 of which are entry level, 44 and 11 for wastewater, and 2 and 1 for water conservation. All right, so I'm going to focus on the engineering and construction department here. Since that's where most of our positions are, we want to give you a little bit more detail on the various divisions within this department. So first we have is the Water Distribution Planning Division. And you'll be hearing more about that later from Bill Majori. Bill Majori will be next on the presentation, actually, and Bill will talk more about this division. But essentially, they are in charge of planning all of the infrastructure. The second division is our design division. They are in charge of taking what planning has done and figuring out how do we actually design this facility. So there's a lot of lots of details in this division, coming up with drawings, coming up with feasibility for construction, all the sorts of infrastructure we have, whether that be structural, water treatment plant processes, mechanical design, all those sorts of things. The third division is our pipeline infrastructure division. Since we are a drinking water agency, we have a lot of drinking water pipelines. So we have a whole division that's in charge of coming up with the drawings for pipelines, figuring out coordination with other utilities. And an exciting one is pipeline innovation as well. Our pipeline rebuild program looks at what are the best materials for earthquakes and all the various hazards we have in the East Bay, and also what are the most innovative construction methods. Fourth division is our engineering services. This is kind of a lump all of all the other engineering we have at EBMUD, which includes geotechnical engineering, cost estimating, specifications, and also our mapping services, since we do a lot of GIS work within EBMUD. And our last division within engineering construction is our construction division. So these people are in charge of contract management. So EBMUD will hire contractors to build many of our facilities. This division is in charge of making sure the project is constructed as we intended it, make sure the contractor's staying on schedule, inspections, drawing submittals, and also change orders as well. So from here, I will turn it over to Bill Majori, and Bill is going to talk about water distribution planning. And Bill's also my old boss.
Thanks, Max. Hi, everybody. So yeah, as Max said, I work in the water distribution planning division. Of the 52 entry-level positions that Max talked about earlier, 9 of them are in our division. So that means we have a lot of young engineers, many of whom socialize together. So it's a pretty cool environment. So our division supports the replacement of our Asian infrastructure, which includes things like pipelines, pump stations, tanks, treatment plants. And we determine the need for infrastructure projects and plan the size and location of new and replacement facilities. Like in the upper left-hand corner, this 37 million gallon reservoir that was demolished. It was actually built in the 1800s in the Berkeley Hills, and we recently replaced it. So as we renew our infrastructure, we do so to meet kind of several goals. First, what we do is we size our infrastructure to reliably supply water and fire flow protection to our future customers and our existing customers, accounting for all the potential growth that's occurring in the service area. In the bottom left-hand corner, you can see kind of downtown Oakland, and a lot of these white buildings are a lot of the new buildings that are getting constructed in downtown Oakland. There's a lot of that going on in our service area, and we're planning for that. Now, East Bay Mud is known for excellent water quality. We size our infrastructure to help improve water quality by minimizing the time it takes to go from a water treatment plant to our customers. Our service area, I think Max mentioned this, that there's a high probability of earthquakes in our service area, and shown in the upper right-hand corner. We plan our water system to make it more resilient with every decision we make, because our goal is to make sure that we can recover quickly from potential emergencies and disasters, like earthquakes, widespread power outages, droughts, or just individual pipeline breaks or pumping plant failures. So we work out the details to ensure our infrastructure is also integrated into the surroundings and minimize the environmental impacts during construction. On the bottom right-hand corner, you can see kind of a rendering, an architectural rendering of a pumping plant that was built on Mount Diablo Boulevard in Lafayette. And so that's something we do as we start planning our facilities. And then finally, we develop a pretty good understanding of our complex water system and how it works. And therefore, operations and maintenance reaches out to us to help them make decisions about different operational strategies, but also responding to emergencies. So we have a role in the emergency response team. So next slide, please, Max. So probably one of the most well-known tools we use in our group is GIS software and hydraulic modeling. There's a picture of a hydraulic model on the left-hand side of the PowerPoint. We use this to analyze and make decisions about our water system. And this is one of my most favorite parts of the job. I like it, it's really technical. We plan, you'll learn how to plan specific projects when you come to water distribution planning. Like in the upper center of this PowerPoint, that's like a plan for the replacement of a large reservoir with 2 smaller reservoirs, as well as you'll get some experience working on master plans. And these are things that kind of look at the long-term plan for portions of our water system. In WDPD, that's shorthand for Water Distribution Planning Division, you'll learn how to make presentations and communicate complex topics effectively and clearly. Decisions that we make guide the actions of design, construction, operations, and maintenance. So we make sure to work closely with those groups, those stakeholders, to get their input into our decisions, but also to make sure they understand what they are going to be implementing later. In addition to verbal presentation skills, you'll get some skills writing reports. We write reports for the community, environmental reports. We also write technical reports internally to document our plans that will be implemented later. And then finally, we manage projects. We have consultants that we manage, like environmental consultants and architects. And you'll get skills doing that, but also managing our projects and with the goal of meeting our schedules, our budgets, and completing the scope of the project. So I'll kind of conclude here by saying that, East Bay MUD is at an exciting phase right now. We're undertaking more infrastructure projects than we have since I've been working here in the last 24 years. And the staff at East Bay MUD, they're quite knowledgeable, friendly, passionate about their work, which makes for a pretty good work environment. Now, the best part of working in planning is you develop a really good understanding of our complex water system, like I mentioned before, and you're going to be making decisions to improve it for future generations, decisions that'll last, maybe over 100 years. So, as part of planning, you'll see the entire lifespan of the project from an idea to a concrete piece of infrastructure. And therefore, you get that big picture understanding of the life cycle of a project. So I really like this part of the job. It's something I take pride in and get excited about. And hopefully this gives you an understanding of the type of work we do and which you would learn in water distribution planning. So I think I'm going to conclude here, and I'm going to hand off the presentation to Lori Work, who's a senior engineer in the process engineering group, and she will talk about what they do in process engineering.
Hi, everyone. I'm Lori Work, and I'm the senior in process engineering. Bill just said that. We're part of the Office of Water Quality, which is in the Water Operations Department. When Max was showing the diagram of all our different departments, this is part of the Operations and Maintenance Department. So engineers are a minority in that department, but we do have a strong presence. Much of the work that we do is in the field of environmental engineering, but we do other civil engineering work as well. And all we need from a junior engineer is problem-solving capabilities and a willingness to learn. Our primary purpose in process engineering is to support and advise the water operations teams on technical water quality matters most. The groups that we support include our water supply division, water treatment plant operators, distribution system operators, and water system inspectors. My group's most immediate concerns are the protection of public health and continued compliance with drinking water regulations. By the way, I don't know how many of you can see me actually right now, but the photo behind me was taken at one of our water treatment plants. These are the flocculation and sedimentation basins, and they're reflecting the sunset. It's a really beautiful picture that my manager, Susan Tiffy, took. And she's a great boss, so I really hope she doesn't decide to change professions and become a professional photographer. Anyway, much of the recent projects in process engineering have been related to changes in source water quality that have been brought on and will continue to be more frequent due to climate change. We are facing droughts, landslides, powerful storms, and wildfires, and all of these impact water quality, as you can imagine. So we've been testing the feasibility of treating the water that is different from our usual extremely good water quality, because occasionally these natural disasters mess with our naturally good water quality. Both our regular source water our regular source water can get impacted water quality wise, like I said. And then also because of drought, we have to look at alternative supplemental water supplies. So these have a different water quality than what we're used to. So our group looks at how our current water treatment plants should be operated under these varying water quality conditions. And we also look at new technologies and water treatment plant improvements that the district has planned. So our group seeks to understand how these new processes that are in planning, design, or even construction right now are going to impact our water quality. We do a lot of water-related research in our group, both hands-on and literature reviews. So some of it's in the field and some of it's at our desks. Our field work is done at 3 different scales. Some things can be done at what we call the bench scale, and it's called that because it doesn't require a lot of large fancy equipment. It's done with smaller things like bottles and small instruments and things that can fit on top of a countertop. Other studies are done at our pilot scale water treatment plant. So EBMUD's real full-scale water treatment plants operate somewhere on the order of between 10 million gallons a day and well over 100 millions of gallons per day, depending on which of our 6 plants we're talking about and what time of year it is. So in contrast, our little pilot plant produces a maximum of 2,000 gallons per day. So it's still a lot of water when you look at watch it flow, it's still a lot of water, but it's nothing compared to our real plants. And the benefit of having a pilot plant is that we can try things out without worrying about process upsets, because none of the customers are drinking this water. And we're currently working on designing a new and improved pilot plant, which will have more space and include additional advanced treatment processes that EBMUD is planning on making. So, or putting in place in our full-scale plants. So our pilot plant needs to be able to change before the real plants change so that we can help plan for these changes. We also design some studies that can be tested in the full-scale system. So these can be done in the water treatment plants or in the pipes or the source waters or the treated water reservoirs. We work with treatment and distribution system operators to design sampling plans and alter variables and study the impacts. We review the plans that come out of Bill's Water Distribution Planning Group and also designs that come out of our design division. And we look at these from a standpoint of water quality and drinking water regulations and provide input from that standpoint. And basically in general, we do a lot of data analysis, produce a lot of reports, and do a lot of presentations. So next slide, please. So here are a sampling of photos taken during the course of process engineering work. In the top is a pontoon that's ready to be deployed and anchored in our San Pablo reservoir. So that's a reservoir that's located, it's near Orinda, if you're familiar with the Bay Area. It's one of our smaller source water reservoirs. And it had this pontoon that we're launching has an instrument attached to it that goes up and down through the water column several times a day, measuring water quality parameters. EBMUD is planning to construct a hypolimnetic oxygenation system in the reservoir, and we want to be able to measure the water quality before and after to see what those impacts are. The top center photo is of a rotation engineer. Winnie's going to talk about the rotation program later, but she's a rotation engineer working in process engineering at our pilot scale water treatment plant. And the current pilot plant is located inside one of EBMUD's our largest pumping plant. So the yellow thing, the big yellow thing in front of her is actually one of those big pumps. And these were built in the 1940s. There's some older ones on the other side of the building that were built in the 1930s. But they still work, and we run them when we need the extra supply on our raw water aqueducts. I wish I had a good photo of the actual treatment processes in the pilot plant, but because they're crammed in between these pumps, they're really difficult to photograph. So we are definitely looking forward to our new pilot plant that we're building. On the upper right-hand side is a photo of a little boat leaving the dock inside one of our larger underground treated water reservoirs. And this photo was taken during a sampling study. And just to know, in case you're worried, this boat is only used in treated water, and staff never touch the water with anything that isn't designated for treated water. And everything's disinfected between uses. On the bottom left is a photo of an engineer that's testing water quality of a water treatment plant sample. And in the bottom center is a page from the California Code of Regulations, Title 22 on drinking water. It's kind of our Bible in my group. And on the bottom right is another rotation engineer working in process engineering. She's standing inside one of those raw water aqueducts that Max was talking about, the ones that are used to bring water from Party Reservoir 85 miles away to the East Bay. And obviously the aqueduct had been drained or she wouldn't be standing in it. It was drained for inspections. We also do this makes it look like all we do is spend our time in the field, and that's not true. We also do our fair share of office work, for better or for worse. And at this point in time, most of it's done telecommuting from home. But I decided to spare you photographs of my staff working in their gym shorts. So that's it for me. And I will pass the baton to John, who will discuss projects on the other side of the system.
All right, thank you, Lori. I'm here to talk about the wastewater side of the system. And in wastewater, we have all of the three major components of a project that the water side has three separate divisions for: planning, design, and construction. In wastewater, those are all consolidated together in a single wastewater engineering division. And we have 44 engineers, and 11 of them are the junior assistant engineer level, the entry level engineers. And in the wastewater project and construction management, we have 4 of those positions. And so it's a really good exposure to both wastewater and wastewater treatment, as well as general engineering concepts and training. The purpose of this section, so that's my section, is the project and construction management section. We manage larger consultant designs so backing up, the wastewater design section has over 20 engineers, and they design the majority of the projects that we build in construction and wastewater construction. For the larger projects that are over $8 or $10 million, we'll typically consult those out just for manpower reasons or technical expertise reasons. In any case, those are typically managed within the wastewater on the project and construction management section. In any case, once a project is completed, the design, the construction management section takes the project, the bid documents, we advertise them for bidding, we recommend a board award of the contract for the construction contractor, and then we shepherd the contracts and bonds through the signing process, and basically establish the documentation basis for the contract. And then we go ahead and we manage the construction contractor all the way from notice to proceed. We oversee the construction in terms of making sure that the contractor stays on schedule, stays on budget, stays producing good quality work, all the way to startup, testing equipment, testing systems, and troubleshooting, and handoff to operations. That process exposes you to all the aspects of engineering, from designing change orders to you know, the construction techniques, all of the intricacies of treatment processes and what works and what doesn't work in treatment processes. And then, you know, you get the experience of starting up large systems. It's very gratifying. So the areas of studies that are applicable for these, you know, we actually hire people with all kind of different backgrounds. You know, construction management experience or construction management, you know, coursework is really beneficial. Startup and testing and tinkering and troubleshooting, that's critical as a critical element of what we do, because there's nothing like building a $20 million construction project and then not being able to get it to work. So we try to avoid that, and we really focus on that, you know, making sure all the kinks are ironed out before we hand off a construction project over to operations. And then civil, mechanical, electrical disciplines for both design and again, understanding what's being built. And then, you know, we're responsible for the, you know, general project management and all the tasks associated with that. So on a day-to-day basis, what kind of tasks do our engineers do? A lot. When we're doing construction work, a lot of what we do involves, you know, inserting new pipes or new pumps or new valves into an existing system. And so there's a lot of coordination to manage that disruption to operations so that we don't actually have treatment plant upsets or process failures. So there's a lot of coordination involved in planning those kinds of things to minimize those disruptions and making sure that treatment still occurs. We have, you know, we have to resolve anytime there's problems that occur out in the field, then, you know, we have to figure out, well, how are we going to solve this problem? You know, we thought this was going to be good firm soil, and turns out it's mush, it's applesauce. So how are we building on top of this? It's resolving those kind of differing site conditions. A lot of coordination. It's you know, again, it's project and construction management, a lot of coordination between all the stakeholders, all the way, even sometimes to the public. We have public meetings that we have to attend sometimes to present or talk about our projects. We interface with the public when we're about to mobilize for a project that's out in the public streets. We have lots of coordination meetings with operations and maintenance to make sure that they're aware and they're bought into, you know, whatever it is that we're trying to build, to make sure that they have their input into the design so that we get it right the first time. When we do the handoff, you know, there's a lot of training and you know, and troubleshooting that we work with operations and maintenance very closely, right down to the take it over and start putting it in service. So, and I have a few photos of some sort of representative projects that we've done. So in the upper left corner there, what we're doing here is we're coating concrete, right? So wastewater, that's one of the things that's really interesting about wastewater is it's a really tough service. It's abrasive. It's got biological activity. It's got it has chemistry going on that's very corrosive to concrete and steel, and so anyway, so this photo is it's, you know, showing how we have to prep. You know, it deteriorates the concrete in our systems, in our tanks, in our pipes, and we have to go in periodically and rehab that concrete so that we don't get a collapse and a street fall in. So this photo is just showing a roughness profile that we have to, you know, verify that we're going to get good attachment of a repair mortar on a concrete tank. So, and then moving to the right, we had to install an overhead power line for one of our facilities. And so it was just very photogenic. So we do, anytime you put in a new piece of equipment here on the ground, you have to wire to it. And so, we have to work out the detailing all the way from the switchgear, either underground conduit duct bank or overhead wire, which we don't have a lot of at the wastewater plant. In addition to all the piping and pumps that you see, there's all this other utility infrastructure that goes along with it. And then the next item is it's a large pit excavation. So East Bay Mud sewer system, we're not like a city sewer system with 6-inch to 12-inch pipes. We are the interceptor system. So we have about 30 miles of pipelines where all of the individual city agents, all the cities that are tributary to us, that they have, hundreds of miles of small diameter pipe. We have about 30 miles of large diameter pipe, and it ranges all the way from 42-inch pipelines to 105-inch pipes. And some of which are, were cast in place. They aren't pipe that you buy off the shelf. They're 105-inch, foundation slab and horseshoe sewer, like you might see in the movies. But this was a cab project where we actually slip lined, I think in that case it was the 48-inch pipe into an existing 54-inch concrete pipe. And then moving again clockwise, in the lower right there is we're about to install a grit conveyor that is moving. It's going to move sand and grit out of our one of our settling tanks, and we pump it basically to trucks for removal. But this is one of the things that's interesting about wastewater is all the crazy kind of stuff that comes down the pipe into the plant. We just have to deal with it, whatever comes in. And so, so we've had these grit conveyors in place. We have eight large grit tanks, and they've been in place for about 50 years. And so we're in the process of replacing them. Just completed the replacement, actually. We put in, the flights that you see are about an inch thick on the conveyor screw. And it's just a really challenging thing to ask of equipment to keep functioning for 50 years in a service like that, where it's, it's basically like moving sandpaper around all day. And then the next little note taking there is just an example of some startup testing that we did on a project. And again, every time you put a new piece of equipment in, you have to confirm how it performs and document that. And so that's one of the day-to-day tasks that we do. The next item is another shot of that, the interceptor work. So the lower left corner, it's all of the design engineers. We had structural, we had geotechnical, we had a couple of project engineers, an inspector. We had a whole team out there, and I think we were just inspecting the work on a field trip. I don't believe that there was a problem that occurred, but I thought that was an interesting photo because it showed like 8 of us all lined up there looking in a hole at a piece of pipe. And then just the last thing is the cover sheet to one of our plan sets. So like I mentioned on the last slide, we take a project from, essentially from the beginning to end in construction. So all the way from the day that we advertise for bids until we hand off to operations. That is the role of my section in wastewater. So I think that's all I have. So with that, I think I turned it over to Brad next.
That's right, John. Thank you so much. Hi, everyone. Thank you for joining us this evening. We really appreciate it. I'm going to talk to you a little bit about the Water Supply Improvements Division. Weird name. I think a better way to think about it is we are the water supply research and development arm of East Bay MUD. I've got this picture of Party Reservoir behind me, and one of our focuses is trying to help the district become resilient and to climate change and a lot of different things that are going on. In the upper left there, you can see we have a Venn diagram. We're really broken up into sort of recycled water, water transfers, and regional projects. A junior engineer coming to work in Water Supply Improvements Division will actually get experience in all three of those areas. They got a picture of our group. Linda Hu is our manager. Florence is the supervisor of water recycling. They do a lot of really cool stuff, reverse osmosis. They track regulations, looking at potable reuse. They have residential fill stations. They also provide support for operations of our recycled water system where it's been built. We got Hassan, who's in charge of water transfers, and they are really heavy right now into the drought. And that's what they're involved with right now, helping to bring water supplies into the district. And then there's regional projects, which is the group that I oversee. And so we'll do groundwater, local storage, desalination, agency partnerships. I have another slide that I'll talk about a little bit more detail about what that group does. I've got some quotes down there at the bottom. I'm not going to read them to you, but really WSID is a really tight-knit group. Everyone's really friendly. It's more family oriented. Everyone pitches in. It's a really, really great place to work. Next slide. Talking about regional projects, a junior engineer coming into regional projects, you are going to work with other agencies. You will be making contacts at other agencies. I've got some icons there just to kind of give you an idea. But every day, every week, every month, we're on the phone, having meetings, talking with a lot of different agencies. Because what we do is we reach out, we develop partnerships, and that's how we develop these new water supplies. We also participate in a lot of stakeholder engagement and messaging meetings and efforts. Being a junior engineer coming into water supply improvements and especially regional projects, you're going to learn about how to lead a stakeholder meeting. How do you set it up to have a positive outcome and avoid sort of negative outcomes? When's the right time to do a press release? And in doing that, we're going to be bringing on and working on some of the most innovative projects that I've seen here at the district. We've got the Los Vaqueros Reservoir Expansion Project. We've got Bay Area Regional Reliability, and I encourage you, please go Google BAR East Bay, and we got a website, you can read all about it. We're continually looking for ways to find Freeport and integrate it further into the district's operations. And then regional projects really handles everything groundwater, whether it's local groundwater banking or non-local groundwater banking, SGMA, Sustainable Groundwater Management Act. We're actually in the process of creating a groundwater sustainability plan. In regional projects, you'll have the opportunity to work on groundwater modeling, collecting data, analyzing it, working with stakeholders within the watershed and also the local watershed and also the groundwater basin. And then we also, because we are bringing in new water supplies, we also do hydraulic modeling of the raw water system to figure out how do we get those new water supplies in and under what conditions. So I really hope you apply and would love to see you. So with that, we're going to turn it right back over to Winnie, who's going to talk a little bit about a career at East Bay MUD.
Hi again, everyone. So we have the engineering career pathway shown on this slide here. And this is something I really appreciate about East Bay MUD because they're completely transparent about your salary and your career pathway. You start out as a junior engineer and it starts at $98K and goes up to $119K. And the job requirements for the junior engineer is you have to either have a EIT or you can have a bachelor's in engineering. Or if you're like me, you could have a master's in engineering and not have your undergrad in engineering. The next step up is the assistant engineer. And this is a salary range from 113 to 138. And it's called a promotion by competitive standards, basically meaning that you don't have to wait for a job opening and apply for this position. You just have to meet the job standards. So it requires 2 years as an experience for junior engineer, or if you have a master's degree, you can substitute, or you only need 1 year as a junior engineer. So after that, we have associate engineer, and this one you do have to apply for. It requires a professional engineering license and also 4 years as a engineer. And then after that, we have our senior engineer, and this is our first like engineering position that's a management level. You do manage a small group. And then after that, we have engineering manager. Next slide. So another really great thing about East Bay MUD is the rotation program. And this is a program that almost every single engineer participates in, or at least junior engineer. And you go on 2 rotations that are both 6-month long. And our rotation program manager, he'll try to work with you on where you'd like to rotate to. We have a lot of the groups that you can rotate to listed down below. It's a really great way to learn new skills. And if you're interested in getting exposure to a different group, like you would like to work there in the future, then it's a good way to get exposure to it. So I personally wanted to try something different from my group in water distribution planning division, which is the division that Bill is working in. And I did 2 rotations in the operations department. So my first rotation was in water loss control technologies. Next slide, thank you. And I really like this group because it has a lot of research and development in it, and they focus a lot on piloting new technologies. So the first project I worked on was called satellite leak detection. And this is pretty cutting edge. It uses technology that was originally used to look for water on Mars. And instead it uses radar here to detect chloramine in drinking water to find leaks. So East Bay MUD was actually the first agency in, I think, all of North America to pilot this. So it was really cool because a lot of other agencies who are interested in it will come to us and ask us about what our experience with satellite leak detection was. Another project was using these specialized pressure monitors. They're called PipeMinder S's, and these are different from normal pressure monitors because they record at extremely high frequency, high resolution data, and that lets them capture and detect pressure transients. So these transients, they're really damaging to our pipelines, and my job was to use these monitors to kind of figure out why these transients are happening and how to resolve or prevent them. So we know that the transients were caused by rapid changes in water velocity, but kind of figuring out why that was happening required a lot of teamwork with different divisions. And that was really cool because I got to work with like a lot of operators or instrument techs to try to figure out whether the transients were caused by maybe how we were operating the system, or maybe there was some sort of instrument that wasn't working correctly. And it was just a very different experience from planning, which it's planning is a lot of solo hydraulic modeling work, and we don't really get to go out into the field as much. So definitely a different experience from planning. Next slide. So my second rotation was in water supply engineering. And like the name suggests, this group mostly works on the raw water supply end. So I have our raw water supply end system kind of shown here. And this is something that I always wanted to work with just because I did my undergrad in hydrology, and I kind of imagined myself working with hydrology in the future, but I just never got the chance to. But fortunately, our rotation program manager was able to kind of work with me on my interests and let me get a chance to work in this group. So this group is cool. It's pretty cool because half of this group is they're hydrographers, and the hydrographers help us collect data, and engineers will then use this data to update models for forecasting our water supply. And if you didn't know, we're in a pretty dry year. It's the driest year on record since the 1970s. So it was a pretty crazy time to be working there. Every drop counted, so it was really important to have a very accurate model. One of my projects was creating an evaporation tool. And we were previously relying on historical averages to kind of estimate evaporation from some of our reservoirs. But We all know, like with climate change, historical averages are not necessarily going to be representative of current or future conditions. So I was building a tool that was calculating evaporation on actual hourly conditions. Another cool little side project I did was a bathymetry survey. So basically our team spent a few days just cruising on a lake, and we used this little red jet that's shown on the screen to map out the reservoir floor by, it would use LiDAR beams that would shoot to the bottom of the floor. And then, like I mentioned before, us planning folks, we don't really get to go out into the field as much. So this is a nice little treat. And I think most of the managers that are part of the rotation program, they always try to make the experience fun. And they'll carve out, interesting projects and trips for you to experience. And then now I'll pass it on to Max Pfeffer.
All right, thanks, Winnie. So from here, we'll be moving on to salary and benefits. Who doesn't want to hear about money? So our starting salary at EBMUD will be $97,992, and that is with no external experience. If you have some documented level of experience, like you have some prior salary, EBMUD has a procedure on making sure you get the appropriate salary based off of your experience. So the $97,992, that's where most people start out at the junior level, but you don't necessarily have to start out that low depending on outside experience. So there was a survey from UC Berkeley civil engineering graduates done in 2019, and the median salary of those graduating engineers in 2019 was $69,000. So even after you account for inflation over the past couple of years, we are well above the median of what a UC Berkeley engineer would be getting. And that's primarily due to the private sector, the consulting engineers paying far less than the public sector employees. I've written on the slide is EBMUD is highest among Sacramento and Bay Area agencies. We are among the highest. We are not actually currently the highest. Valley Water holds that title. But I will mention that EBMUD is currently undergoing contract negotiations with our unions. So that's another benefit of being part of EBMUD. You are part of a union and you will join the local 2019 union. So these contract negotiations are ongoing, and there may be a change in salary from that $97,992. And typically there is some increase for each year of our contract. So that's the starting salary numbers, but that's just the beginning of the benefits we have at EBMUD. And hopefully I don't come off too much as a used car salesman, but there are a lot of great opportunities here at EBMUD, not just the salary number, which is good. So the growth opportunity, like Winnie mentioned on that ladder slide we talked about before, you have the ability to quickly promote to the assistant engineer level, which is roughly between 114,000 and 138,000. And as a reminder, that's with two years as a junior engineer, or the equivalent of 1 year as the junior engineer with a master's or a PhD degree. And one other thing to add on to that is you will pass a probationary period in order to be able to advance. When you start at EBMUD, that probation period is 1 year. So you have to wait at least 1 year before you can get promoted to the assistant engineer level. Other benefits we have: 12 days of paid vacation, 15 holidays, and 13 days of sick leave. And from our look at other water agencies within the Sacramento and Bay Area agencies, we are among the best benefits in terms of paid leave that you'll see out of any other agency. Some other important things: you'll have fully paid medical and dental, you'll have a pension, you will have access to a deferred compensation plan. So this is like a 401k, those sorts of things, a transit to use public transit, a subsidy to use public transit, or even to bike or walk to work. And you'll also get a $3,500 per year tuition reimbursement. So if you want to take classes on your own time outside of work, you can apply for up to $3,500 in tuition reimbursement. And I'll just quickly go back to the pension thing a little bit. EBMUD has its own pension program that actually Tim McGowan is one of the trustees / retirement board members that manages that pension plan. So when you retire and you worked X number of years at EBMUD, assuming you're here a long time over a 5-year limit, you will get a pension for every month of your life until you're dead. That is a very valuable benefit that you will not see at private institutions. So that's just another thing as you're looking at long-term planning. EBMUD is looking at you from the beginning with a nice high salary all the way through your retirement and looking at having a pension. Some other non-monetary benefits we have at the district is a compressed work week. So this was actually a big one for me when I was looking at places to work. So a compressed work week is, instead of working Monday through Friday for a 2-week period, you can actually compress your schedule and take one of those days off. So typically people take Fridays, one Friday off in a 2-week period, and use those hours you would have worked on that Friday and spread it out over that other 9 days you'd be in the office. So it kind of gives you a 3-day weekend every other week, but you still maintain the same salary and the same number of hours that you're working. We have our own employee wellness programs. We have gyms at many of our facilities that we have, I think, 4. One our admin building, one at our treatment plant, our main wastewater treatment plant, and I believe there's 2 others at other places. And then we have affinity groups or employee resource groups, and I'll talk about that on the next slide. So in terms of diversity, equity, inclusion, and justice at EBMUD, one big part of the diversity aspect is our employee resource groups, which are listed below. The first we have 4 currently at EBMUD. The first of which is the Asian Pacific Employees Association. And Winnie Jung is actually a big part of APEA. And that is, as the title suggests, for Asian Pacific Islander employees. But all these affinity groups are open to all employees. It's not just for whatever group that's been designated to. We also have the Black Employee Network, which is one of the oldest affinity groups at EBMUD. Fuerza Latina, which is for our Latinx community, and then Reigning Pride, which I'm a part of, which is for our LGBTQIA+ employees. So these are the 4 we currently have. There are currently 2 more affinity groups in the works, one of which is for disabled employees, and the second of which will be for veteran employees. So that's one angle on the diversity side. On the more holistically with diversity, equity, inclusion, and justice, EBMUD embarked on the Racial Equity and Justice Project in 2020, and we are currently working on the Diversity Inclusion Strategic Plan. And those efforts are holistic across our organization, trying to look at all of our business practices. How can we incorporate racial equity, racial justice, and diversity, inclusion, equity, all of that across our organization? So on the context of junior engineer in this open house, one of the big focuses of those plans is focusing on creating a more equitable hiring process. So since we are a government agency, there are limits on what we can do. We are not allowed to do, we have an affirmative action plan, but you can't hire based off those categories. But there's a focus on creating a more equitable hiring process. So potentially doing more outreach, increasing funding in certain areas. So this is a big focus as part of the REJ project and the Diversity Inclusion Strategic Plan. The EBMUD board, which is our governing body, the public elected 7 directors that I mentioned at the beginning, the board has also done their own actions on passing resolutions, which are essentially like, this is the opinion of the board. That's what a board resolution is. They've done 3 resolutions to date, one for the Asian American community, one for Black employees, or Black people and Black employees, and the third for LGBTQIA and specifically transgender people. So these are resolutions that affirm the position of the board on condemning any hate, intolerance, violence, all these things against those groups. And if you want to read more about those resolutions, they are listed on the EBMUD website. We are also open to additional affinity groups. If you end up working at EBMUD and have your own idea of an affinity group to work that you'd like to form, there's a whole process on how you can create affinity groups. All right, from here, I'm going to turn it back over to Tim McGowan, and Tim is going to talk about the application process. How do you actually get in the door?
All right, great. And for when I was growing up, oftentimes the saying for jobs was the only way to get a job is it's who you know, not what you know. But this being a public agency, we really try to turn that on the head and make it hiring the most qualified candidates, not based on who you might the district. And to facilitate that, we have a 3-step process. The first step is going to be you turning in your application in August 20th, and then we start our step of reviewing those applications, and then after we've gone through our reviews, then we'll invite the successful candidates in for a ranking interview, and then from the ranking interview, we'll establish 3 ranks of our top individuals, and then they will move on to hiring interviews. The hiring interviews can occur anytime over the life of the list. And we have 3 positions that are queued up right now that need to hire off this list. They'll probably hit it as soon as it's available. But this list will be open for at least 12 months and possibly up to 24 months. And so any future position that becomes available will still use the same list. And Max, can you hit the return just once? So to give you an idea of kind of the numbers, I've been doing this process for about 6 years. And what I've seen is I usually get in a normal year between 120 and 150 applications. From that group, I'll have reviewers go through them, and we'll identify 35 to 45 candidates that we'll invite in for our ranking interview step. And then from the ranking step, usually 12 to 18 people wind up in the top 3 ranks. And so what you can gather from that is there's a lot of ties. And sometimes there are no rank 1 candidates. So it's quite possible if you're rank 4, you still might be in the top 3 ranks. Or you may not be in the top 3 ranks to start with, but as the people get hired off the list, when rank 1 becomes depleted, then you'll start getting interviews. And then through the life of the list, we'll hire between 4 to 10 people off this list. And so what that tells you is that in a normal year, you're somewhere in the 4 to 10% of the best candidates to actually get hired at the district. This year's obviously not normal. We're in a COVID pandemic, and I have heard that we haven't been getting as many applicants as we have in prior years, but this would be kind of what I would say on average I would be looking at getting. Let's see, can you move to the next slide, Max? So the application process has a lot of elements to it. And the most important element is the supplemental questions. One thing to kind of know right off the start is oftentimes private employers want to see a cover letter, they want to see a resume, they want to see letters of reference. And for this recruitment, we're not asking for any of those. And not only are we not asking for them, but in fact, if you submit them, they won't be forwarded on to the raters. And so any effort that you're putting into that is really a waste of time. But what we do look at, and we look at quite a bit, is the supplemental questions. Our process is really a point process, and you're trying to get the most points. And I've never seen a candidate who has not answered their supplemental questions well get enough points to move forward in the process. And I say that because I've been reviewing applications for about 10 years now, and I would tell you about half of the people who submit are going to give me 1-sentence answers to each of these questions. And those candidates are almost never move on because these questions are worth so much. To kind of give you an idea of time commitment, When I'm applying for a job at EBMUD, I usually take a full day off from work, and I will spend about 4 hours doing my supplemental questions, and then I give them to a friend or my wife, and I ask them to proofread it, and then I come back to it the next day, and then I polish it off. So don't view these as something that you can just flip out a Twitter response to. View them more like an essay assignment. So then the next, please. So I took this, pretty much straight from the application. If you were to read through our application material, but I just kind of want to highlight them so that they don't get lost in the jumble. What you're trying to do in your supplemental response is describe, your past achievements and activities that best demonstrate your knowledge, skills, and ability in each area of work or performance. It doesn't necessarily need to be work experience. This is an entry-level position, so they can be academic. I've seen plenty of successful candidates who've told me about, their class projects or their capstone project. And so that's definitely relevant experience, things that you'll want to discuss. You want to highlight what you did on the project more than what the project's about. And I say that because I've had some candidates who've worked on really fantastic projects. So, one in particular worked on the expansion of the Panama Canal, but they didn't tell me what they did. And so they actually didn't score a lot of points. And that would hold true for your interview as well. Don't forget to highlight what you did. Even though it may be a really interesting project, you don't want to devote space to just the project. Try not to use the same achievement in more than one category. If you only have one good example, then sure, use it. But really, we've asked you 4 questions. To maximize your points, you really want to have 4 different examples of projects that you've worked on. And then the final bullet, and in some ways I actually think is the most overlooked, is that we're reviewing your responses based on your ability to write, concise, well-organized document using correct grammar, spelling, and punctuation. And this isn't a test. It's not cheating to have review your essays. So, if you have an English major who's really great at grammar, definitely have them read your entire application. Nothing comes across worse than, reading through someone's application and, they misuse their capitalization, they have improper grammar. It really detracts from your overall presentation. All right, so next slide. So we knew that telecommuting would be dear to everyone's heart. And, the question is, can I telecommute? And the answer to that in a nutshell is it depends. It depends upon the nature of the work that you're assigned to. Some of our junior engineers are in construction management. They have field work that they're inspecting on a daily basis. Those engineers are in person throughout the pandemic. We have engineers that are more office-based, like the people in my staff, and they're currently working full-time from home and have since March of 2020. When will we go to less than full-time? I really can't predict, to be quite honest. We thought we were coming back in August, but at the last minute, there was kind of a new spike in cases, and so we put our reconstitution plan on hold. So as it is, we're still in the pandemic from home. We're working on a long-term telecommuting policy. We expect that policy will be completed before crop of junior engineers gets hired. I don't know all the details that are going to be in that plan, but the 2 things that have become pretty clear is that it'll continue to be something that's at the discretion of your supervisor, and that all employees will have some in-person work requirements. So we're not anticipating having anyone work full-time telecommuting, so you won't be able to, live in Hawaii and phone in your assignments. You'll be expected to show up from time to time. And with that, it brings us to Q&A. We've answered a lot of questions in the text box, but if you'd like to give a verbal question, please raise your hand, and then we'll call on you, and we'll see if we can answer your questions. While I'm waiting for hands to raise up, let's see what showed up in the chat. Does your score on questions play a role on your panel interview, and does your panel interview score count towards the hiring interview? And the answer to that is no. Each step is a separate process. So everyone who clears the supplemental question hurdle will move on to a panel interview, or what I like to call as a ranking interview, and you start fresh. So even if you were the lowest scoring supplemental question candidate, you could still wind up in rank 1. And then really, your panel interview score doesn't count towards your hiring interviews. We're going to send the top 3 ranked candidates to the hiring supervisors, but the hiring supervisor can and often, does hire someone who's not the rank 1 candidate. And that can happen because oftentimes, this is a general list, but we're hiring for particular skill sets. And so if you're rank 1, but you're really specialized in geotechnical skills, then you may not get hired in the wastewater construction management project if they're looking for someone with a different skill set. And so I would say everyone invited to the interview has an equal shot at the position. Next question in on the chat was your score on the application review will determine whether you were invited to the interview panel. And that's absolutely true. It's the whole application, but the supplemental responses are a big part of that. And then the next part of that is your panel interview score will determine your rank on the hiring list. And that's absolutely true. And the hiring interviews will determine who's selected. Oh, sorry, Sandra. That's you replying.
No problem.
Got it. Okay, very good. And then that for the questions that are in the chat that haven't been answered. Are there any hands raised that I haven't seen?
Hey, Tim, while we're waiting, if there's any other questions, I just kind of wanted to do another plug for the rotation program.
Okay.
The rotation program, for all you listening, that this is a really unique thing to EBMUD in particular when you look at the Bay Area agencies. To my knowledge, the only other large utility that does a rotation program is Metropolitan Water District down in Southern California. But the rotation program is a really great way to get experience outside of what you've been hired into. I remember, so I graduated from UC Berkeley in 2016, so I'm still pretty new to EBMUD. When I was coming out of UC Berkeley, people were telling me that, oh, if you work for a public utility, you're going to get pigeonholed into one job and you're not going to get the wide variety of experience you would get from if you worked for a consultant. That was something that was told to me by lots of different people. But what I found from EBMUD with the rotation program and just the number of engineers that we have in-house, I've been able to have a lot of different experiences within EBMUD. So for my rotation, my home division was water distribution planning, where Tim, Bill, and Winnie are. And then I rotated to the water supply improvements division, which is currently where I am now as an associate engineer. My second rotation was in the construction management division. So I was able to get 2 very different experiences from where I was. So just wanted to offer that as another plug of, it's a really great benefit that we offer.
We've had a few good questions come into chat. I am reminded, though, we wanted to stop the recording so that people wouldn't be inhibited on asking questions. So if perhaps Amy could do that for us.